In this lesson, we're going to practice factoring higher order polynomials. So we've factored quadratics, but now we're going to factor expressions that are higher than quadratics. All right, so this first one, we're going to factor it, and we're going to sketch a graph based on our factors. So we start with this one, and if you notice, we've got a GCF here. So I'm going to factor out 3x, and that's going to leave me with x squared minus x minus 2. I'm going to continue to factor because x squared minus x minus 2 can be factored further. Now I'm going to use these factors to find my zeros on my graph. What makes 3x equal 0? 0. What makes x minus 2 equal 0? That would be 2. And x plus 1 would be negative 1. Now from here, let's look at our original problem. It is odd positive. So that means the end behavior is going down and then up. So from this, we can sketch our graph. And we're not looking for exact points. We just want to have the basic shape. So I know it does something like that. I've got the correct end behavior and the correct zeros. All right, let's do the same thing for letter B. Let's take out the GCF of x. And then I've got x squared minus x minus 20, which factors further. X minus 5, x plus 4. So we have 0, 5, and negative 4. Once again, it's odd, x to the third, the degree, and it's got a positive a value. So the end behavior is down, then up. So we're going to go this way, and this way, and this way. And that's our basic shape. Again, we're not looking for the exact shape. We're just looking for something with the right end behavior and the right zeros. Next up, let's factor out 2x, and that leaves me with x plus 3. Okay, we can't factor any further, so now we pick out our zeros, 0 and negative 3. Now notice this is to the second degree. It's even, and it has a positive a value, so the end behavior is going up and up. So in other words, this one looks something like this. And we'll do the same thing for letter D. GCF of 10, and I'm left with x squared minus 5x minus 6. Now be careful with your negative 6 there. I need factors of negative 6 that are going to add up to negative 5. So I think this will work if I use 1 and negative 6. It's easy to want to say 2 and 3, but they have to be different signs, so they didn't work. X plus 1, x minus 6. Now the 10 does not help me with my zeros because it's not an x. I cannot make 10 equal 0, so that doesn't count. But this one gives me a negative 1, and that gives me a positive 6 for my zeros. It is a second degree, so it's even. It has a positive a value. So it looks a lot like the one right before it. Something like that. So just a little practice on finding the zeros and how we graph once we found those zeros. On this one, it talks of factoring by grouping. So when you see 4 terms, we're going to factor it by grouping. What that means is we're going to take the first 2 terms and group them together, plus the second 2 terms and group them together. Make sure you always put a plus in between, and if there's a negative sign, it's going to hang with the number behind it. That's very important. Once we do our groups, we take out what they have in common. So these two have an x squared in common, leaving us x plus 7. These two have a negative 4 in common, leaving behind an x plus 7. So we take the ones that we factored out, x squared minus 4, and then we take the one that they had in common, x plus 7. And notice this can factor further. So it's x plus 2, x minus 2, that's our difference of squares, and then the x plus 7. Take a look at letter B. Now, before we do our grouping, I want you to notice that every single one of these has an x. So I'm going to take out my GCF of x and see what that leaves me. 24x to the third minus 8x squared plus 21x minus 7. Now I'm going to do my grouping with the 4 that are left inside. The x has to stay out here because it's part of the factors. So I'm going to group 24x to the third minus 8x squared plus 21x minus 7. So let's see what this first group has in common. I think they have a 3x squared in common. How about a 4x squared? Wrong number. 4x squared. And that's going to leave me with 6x. Actually, they have an 8x squared in common. All right, it's okay to not be perfect the first time. So if I factor out the 8x squared, I get 3x minus 1. And in the back set of parentheses, I'm going to factor out a 7, which also gives me a 3x minus 1. So when we're grouping, we want to have one of the factors needs to be something in common, like the 3x minus 1 here. So what I'm left with is my x, and now the 8x squared plus 7. And then the one they had in common was 3x minus 1. Now my only hope would be, can I factor the 8x squared plus 7 any further? And the answer is no. So that is factored completely. All right, look at letter C. Notice they all have an x. So we're going to do the same thing. I'm going to factor an x out, and that'll leave me 6x to the third plus 24x squared plus 5x plus 20. And now we're going to group them together. So in this first group, in common, I'm going to take out a 6x squared, and that will leave me x plus 4. In my second group, I'm going to factor out a 5, and that also leaves me an x plus 4. So my final answer, my x that my GCF from the beginning, now 6x squared plus 5, and the x plus 4 that they had in common. So those are some examples of factoring by grouping. Let's look at the next page. All right, on my next page, we have another factoring by grouping. There's 4 of them. Notice the GCF first, so let's take that out. And that leaves me x to the third minus 4x squared minus x plus 4. So in my grouping, my first group right here, I'm going to take out an x squared, and that'll leave me x minus 4. And in my second group, I'm going to have to take out a negative 1 so that it leaves me an x minus 4. And since I just ran out of space, we'll come up here. So I have my x, and then I have x squared minus 1, and x minus 4 is what they had in common. Please notice the difference of squares. So that's x plus 1, x minus 1, x minus 4. A lot to unpack on that one. Now, letter B does something unusual. Instead of just saying x squared minus 10x plus 9, which is what we're used to seeing, it says x to the fourth. So it's very similar. Let's think about how we would factor this one first, and then we'll attack this. What are factors of 9 that add up to negative 10? Well, I think I'd go with x minus 9, x minus 1. So the only difference here is that's not x squared, it's x to the 4th. So when I break this up, it's going to be x squared and x squared. And then factors of 9 that add up to negative 10 would be minus 9 and minus 1. And now there's difference of squares in both of these. So we're going to break it down further. It's going to be x plus 3, x minus 3, x plus 1, x minus 1. So there was a lot to do there, but we just drew a similarity to something we already know. The difference is it wasn't x squared, it was x to the 4th. So we just broke it down, just split it in half, x squared, x squared. Let's look at x to the 4th minus 16. Okay, again, let's think about something we know. I know how to do x squared minus 16, and this is very similar. So if x squared minus 16 was going to be x minus 4, x plus 4, this one's going to be x squared minus 4, x squared plus 4. Now I do see a difference of squares in the first parentheses. The second parentheses cannot be factored further. So we're just going to break down the first one to x plus 2, x minus 2, and then we leave the back one as x squared plus 4, because that is a addition, not a difference of squares. All right, letter D, let's look at x to the 8th minus 1. So again, a difference of squares, because x to the 8th is really x to the 4th squared. Just like we did up here, we split it in half. So we're going to split x to the 8th in half. It's going to be x to the 4th plus 1, x to the 4th minus 1. And I think this one's going to go on for a minute. Now the plus is done. I cannot factor that any further. But the x to the 4th minus 1 can be x squared plus 1, x squared minus 1. And now the x squared minus 1 can continue. The x squared plus 1 is finished because it's an addition now. Our rule only applies to the difference of squares. So we end up with this huge thing, x to the 4th plus 1, x squared plus 1, and then we broke this down one final time, x plus 1, x minus 1. There was a lot going on there. Now we're going to talk about our sum and difference of cubes. So this one's new. So if you have, and this one works for addition and subtraction, and it works for cubes. Let's talk about cubes for a second. 1 cubed, 1 to the 3rd power is 1. 2 to the 3rd power is 8. 3 to the 3rd power is 27. 4 to the 3rd power is 64. 5 to the 3rd power is 125. And there are some more we can add in there. But those are some of the common numbers you're going to see here. So what you do is you look at this one and you think, what do I do to the 3rd power to get 8x cubed? Well, 8 comes from 2 cubed. So 2x to the 3rd power. And what number to the 3rd power would give me 27? Well, that was 3. So if you look at your formula up here, now I put two formulas in one big piece, but let me write the subtraction one for you. This one says x minus y, x squared plus xy plus y squared. So in this situation, 2x is actually representing the x here. It's going to go wherever that x was. So my first parentheses, notice it's the same sign as the original problem. I'm just going to write 2x minus 3. Because the 3 right here is going wherever the y was going. So 2x minus 3. Notice this sign is the opposite of the first one. So we're going to do x squared. 2x squared is 4x squared. 2x times 2x. Now it says plus xy, the opposite sign. So x times y, 2x times 3 is 6x. And then this one is always positive. Y squared, and y was 3, so plus 9 is how we factor these. So notice the rules for the signs. We're going to use SOAP. Same, opposite, always positive. Alrighty, let's try letter F. What number to the third power gives me 64x squared, or x to the sixth? 4x squared does that. What number to the third power gives me 125? That would be 5. So for this equation, it's x plus y, that's the one on the top, and then x squared, the opposite sign, and always positive. So the first one has the same sign, the second one's opposite, and the last one is always positive. That was our SOAP. So for this one, x plus y is 4x squared plus 5. Now x squared, when we say x squared, we want to do 4x squared times 4x squared. So make sure you square both pieces. That's going to be 16x to the fourth. When you multiply these together, you should get your first term, 64x to the sixth. Opposite sign, x times y, which is 20x squared. And the last one is y squared, which is 25. So this one is just a matter of practicing this new rule with your sum and difference of cubes. All right, I'm going to keep going with more practice. I know the video is getting a little long, so you can practice these and then check your answers, or you could speed it up if you just want it to go faster. 3x to the fourth, I'm going to split that up into a 3x squared and an x squared. Now, if you put this one into a box, you could. We need factors of negative 24 that add up to 2. So I think I'm going with 6 and negative 4. So I'm going to make my outer term a positive 6 and my inner term a negative 4. And I am done factoring. So if you need to use the box on something like that, do what you need to do to get it factored correctly. And so I know some of you do grouping where you split the middle up into the 6x and the negative 4x. That works as well. This one, difference of squares. It's 3x plus 4, 3x minus 4. Okay, so train your brain to look for the difference of squares. We have a difference of cubes down here. All right, this is a regular old quadratic. What are factors of 36 that add up to negative 12? I'm going with negative 6 and negative 6. You can call that x minus 6 squared, or you could leave it as x minus 6, x minus 6. Notice we're factoring. We're not solving. We're not making anything equal 0. We're just factoring. This one is back to my difference of cubes. So I'll write out a formula for you. It's right above on your page. This is x to the third power, and this is 4 to the third power. So those are the values I'm putting in for x and y. X minus 4, x squared, plus 4x, plus 16. You just have to learn the formula that goes with that one. Now I'm going to group these together. In the first group, I'm going to take out an x squared. In the second group, I'm going to take out a 7. And then I have x squared plus 7, the numbers I just factored out, and x plus 2, the factor they had in common. And finally, for letter F, notice there's a GCF in this one. So I'm going to take out the 2x squared and see what's left. X squared plus 5x plus 6. Alrighty. I need factors of 6 that add up to 5. Notice these are all positives. So if I do a positive 1 and a positive 6, that doesn't add up to 5. I've got to do a plus 2 and a plus 3. And there we go. We have factored completely.